With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In the figure shown, a light containing container is kept on a horizontal rough surface. Coefficient of friction is given here. A very small hole of surface area S is made at a depth of h. The water of volume V is filled in the container. The friction is not sufficient to keep it stationary. You have to find out its acceleration. So what will happen? Understand the concept. So the water, if you see here, it is at rest, right? Since the cross section area is so large, and just it take a exit from here, it get a efflux speed of root 2 gh. We know that efflux speed is root 2 gh if the cross section area of the container is large enough. So if you see any dm mass, right? So dm mass, when it exited, it got some momentum, right? So what is the momentum that this dm mass got? It is into v, right? And we know that the force is nothing but rate of change of momentum. So you have to divide it both side by dt and see the rate with which mass is exiting is what? Into efflux speed is what? The force. And the same force the container will also experience, right? If you see the water particle, it is getting the velocity in this direction because it is experiencing a force in this direction. Water particle, it is experiencing a force in this direction. Container will experience the same force in opposite direction. F and F we have got, it is this. Now if I talk about the dm by dt, right, here density won't change. So what will change? The volume with which it is exiting. So dv by dt, we know the volume flow rate is cross section area times the velocity efflux speed, we know. So if you see the cross section area, it is given. So I will write down, it is S times of E, right? So this will be the dv by dt. You can put it here, right? Rho into dv by dt, that is this, into VE. So this will be the force, right? Now the friction force will also act in opposite direction. So here this is F force, and in opposite direction friction force will act, and it is not sufficient. So it will be limiting friction only, right? So if you see the vertical forces, the normal and mg is the weight, and it will be rho liquid, volume of the liquid, into g, and in the above this will normal reaction will act. So the normal reaction will be mg, that is this. So I will write down the limiting friction that is acting here because it is not sufficient. It is this. So mu value is already given. It is sh by v. sh by v, put it here, sh by v. And n is, so you will get this, v will get cancelled out, rho shg. Rho shg is the friction force. So we want the acceleration, so I will directly write down this, right? Now you can put the values here. So if you put the values, we know that the thrust force is this, right? Rho a, rho s, ve. So efflux speed is this, v square is this, and we got the friction force, it is this, is equals to mass. Mass is rho times of volume into g, into a, and we want this a only, right? So just divide both sides by the rho v, right? If you see here, this is 2 rho sh into g, rho sh into g. So it will be, first of all cancel out this rho. So it will be equals to sh into g only. So finally I will write down the acceleration is sh g by v. Now you can check for the option sh g by v So D is the correct one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.